Okay then guys, just a little intro for the trig equations section here. I'll just run you through this bit of bookwork here and then we'll do a simple example, just by way of a taster to get you feeling comfortable with these questions in this section. Here's an xy axis, here's a general point P at a point coordinate x and y. Here's the origin, and here's an angle theta. So we can define our sine, cosine and tan according to this triangle here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse and tan is opposite over adjacent. So we get these values here. Tan, of course, we can use properties of fractions, divide by OP top and bottom here and here. And then we can replace this by sine and this by cosine. And we get tan is sine over cos. So that's the first thing to note. Now, Pythagoras' theorem for a right-angled triangle gives this length squared is equal to the x squared plus the y squared, isn't it? Divide by OP all the way through, squared. This will become 1. This becomes x over OP bracket squared, and this becomes y over OP bracket squared. If we take this equation again and divide by x squared now, this will be 1, this will be y over x bracket squared, this will be OP over x bracket squared. And similarly, divide this equation by y squared in turn now. This will be x over y bracket squared when you simplify the fraction. This will be 1, and this will be OP over y bracket squared. These three equations can now be written in trig form. The equivalent trig equations are here. We customarily write the second term y over OP first, so that will be sine squared. X over OP is cos squared equals 1. So sine squared plus cos squared is 1. 1 plus tan, here it is here, squared equals OP over x. X over OP is cos. So 1 over cos is OP over x. So that's 1 over cos, which we write as sec. So it's sec squared. And then lastly, if we divide by y, we've got this equation here rather, x over y is 1 over this, which is 1 over tan, which we write as cot, plus 1 is OP over y, which is 1 over sine, isn't it? And we write that as cosec, so that's cosec squared. So cot squared plus 1 is cosec squared. Here's the trig ratios for sec, cosec and cot, just mentioned here just to be absolutely clear. Now the best thing to do for this section, now we've got all the bookwork done, is just do a simple example by way of introduction. So if we're going to solve a trig equation like this, 2 cos squared plus 3 sine x, we can use the property of cos squared and replace it by 1 minus sine squared. And in so doing, we can now see that this is just simply a quadratic equation. If we expand the bracket, 2 minus 2 sine squared plus 3 sine x, and then times by minus all the way through and write this one first, times this by a minus here, and times this by a minus. So we've times by minus all the way through the equation and put things in the proper positions. Now we can see this is definitely a quadratic in sign, so we can factorize hopefully. And in most of the problems we do in this section, we will be able to factorize the equation, quadratic equation. So here, 2 sine squared, well we can write 2 sine x and sine x. Here we've got a 2 and a 1. That's the only product that gives 2. 2 times 1. So it's either 2 and 1 or 1 and 2. And we just trial and error, and experience tells us that if we put the 2 here and the 1 there, we'll get 2 sine squared minus 4 plus 1 is minus 3, which is what we want. And then plus times a minus is a minus. 1 times 2 is 2. So there it is factorized. So this is just simple factorization then, which we should be able to do. And that leads us to solving either this equals 0 or this equals 0. This equals 0 leads to this equation here. And this equals 0 leads to this equation here. And there's no solutions there, are there? So we only need to focus on the possible solutions that arise from this part here. Now this is a simple trig equation. And all we do here is we write the customary cast, don't we? So let's have a look up here. I've drawn a circle, I've drawn cast. I'm looking from 0 to 360 in this particular example. So then we mark off when sign is negative. Using cast, sign is positive here and here. So it's negative here and here. So we draw 2 lines, like so, and we mark off alpha, the associated acute angle alpha, just to remind you, and then we write sine alpha is equal to a half. We drop the negative if there is one to drop. Then we can do shift sign to get the associated acute angle, which is 30 degrees. We can put it in a diagram here and here, and then we can read off the solutions. Now the solutions depend on the solution set. If we're working from 0 to 360, all we need to do is go round from 0 round to the angle in question. So that's round 360 and back 30, which is 330. The other solution is around from 0 to around 180 and add 30 more, so you get 210. But it does depend, what solutions you write depends on the actual solution set that's asked for in the question. In this one we were looking between 0 and 360. And we were working in degrees. Some of the problems are in radians, some of the problems ask for different ranges, and some of the problems ask for general solutions. And again, they're best explained by examples anyway in the section. So all the best with this section then, guys. Hope you get on okay, and I'll catch you again in the next section. Cheers.